Okay, we're doing another heat change question. So again, we're going to be using Q equals MC delta T. The only thing different in this one from the last we saw is we're given Q. We're not trying to find Q. So what are we trying to find? Well, it gives us our Q. It says if it takes that much energy to change the temperature of a 28.7 gram mass strip of copper from an initial temperature of 26.3 to a final temperature of 79.5 degrees, what is the specific heat capacity of the copper? So we're looking for little c, specific heat capacity. So what I'm going to do is rearrange this equation. And to do that, we're going to divide both sides by m and delta T. So we end up getting Q over m delta T equals C. Alright, so let's put some numbers in. We've got 588 for Q. We've got 28.7 grams for my mass. Oops. And delta T. Now, we're going to do that just a little tiny calculation on this side. It's T2 minus T1. You want to make sure you get the right orientation so that you don't end up with a negative, because it would, considering in this reaction, we've got a positive energy. That means we've gained heat. So if you wrote it down as a cooling reaction, you get a negative. In this case, we should get a positive temperature change because we gained heat. So we would have to write it as 79.5 minus 26.3. So we end up getting, whoops, we end up getting 53.2. degrees Celsius. Okay. So we'll put that in here for our delta T. That's our heat change, or temperature change, I should say. That equals C. And that should give us 0.385. Now, units. Well, joules should be on top. And on the bottom we've got grams and degrees Celsius, just like in our equation there. So joules per gram degrees Celsius. So an interpretation of that would be it takes 0.385 joules of energy to raise 1 gram of copper by 1 degree Celsius. And that's all you need to find.